Hello, welcome to Climate Conversations, a monthly look at the latest developments in climate science brought to you by the Met Office. This month's theme is artificial intelligence. As the rise of the machines continues unabated, we'll hear how the Met Office is harnessing the power of machine learning to better understand changes in our atmosphere and weather. But first, each year, leading climate scientists come together to produce a report on our planet's atmospheric health. The document known as State of the Global Climate is published by the World Meteorological Organization and a collaboration of weather forecasters and scientists from across the globe. So why is this report important? The report tracks changes in climate indicators. These include greenhouse gas concentrations, global temperatures, sea level, and the extent of polar ice. By documenting these changes, we can see how human activity, particularly the burning of fossil fuels, is affecting the atmosphere. It's important to remember, climate change isn't just about rising temperatures. It can trigger more extreme weather events, including heat waves, droughts, and flooding. Crucially, the State of the Global Climate report isn't just a catalogue of dry scientific data. It highlights the real-world impacts of climate change on people and communities around the globe. So what are the top takeaways? The latest report reveals extreme levels of global ocean heat content, Antarctic sea ice retreat, and a substantial reduction in glacial ice mass. The highest global annual temperature over land, sea, and both combined, and the greatest volume of greenhouse gas emissions to date, with an acceleration in the rate of those emissions. It's worth highlighting that natural weather cycles, such as the recent El Niño event, can bring extra warming across the globe. But non-El Niño years are now warmer than the strongest El Niño years at the turn of the century. Going forward, while we may not record such an extensive list of extremes every year, it's clear if we don't mitigate greenhouse gas emissions, this is a sign of things to come. Climate change is damaging our world and our ecosystems. Everything points to our natural systems going in one direction, and currently, it's the wrong direction. For decades, predicting the path, intensity, and impact of hurricanes has been something of a mix of science and uncertainty. But now, there's a new player on the field in the form of artificial intelligence. AI and machine learning are revolutionizing our understanding of these powerful storms. By analyzing vast amounts of data on sea surface temperatures, atmospheric pressure, and historical tracks, researchers are developing models that can predict hurricanes with unprecedented accuracy. Like tireless students, the latest AI models are constantly learning from past storms, identifying subtle patterns and zeroing in on factors that may have been previously overlooked. Some machine learning models are already being used to provide early warnings of extreme events, and the potential benefits are enormous. Earlier and more precise warnings give coastal communities precious time to prepare, saving lives and billions of dollars in damage to infrastructure. The value of AI forecasting doesn't end with hurricanes. From optimizing renewable energy production to managing sustainable agriculture, AI is set to be a game changer in our efforts to slow climate change. To learn more about the use of AI here at the Met Office, Clare Nasir spoke to two experts in this fast-moving field.
AI aims to create intelligent machines that can learn and problem solve like humans. Machine learning is a powerful branch of AI. By crunching massive data sets, it helps researchers uncover hidden patterns and gain deeper insights. We'll now hear from Professor Simon Vosper, Director of Science at the Met Office. Simon and his team are at the forefront of this exciting intersection between AI and climate science, where machine learning is currently supporting the ongoing work of existing climate models.
Okay, so currently I think we're using machine learning throughout the value chain, if you like. So if you for either a climate or a weather prediction, it all starts with observations. So we use machine learning in processing our observations, in quality control, in maybe understanding those observations. There's some really nice developments in climate science looking at very old historical observations where maybe the data quality's not very good or there's missing information. we can use machine learning to recover those observations and actually make them much more useful. So we're using it in observations. We can use it in the simulation step. So either replacing the full climate or weather model, the complex physics model, we can emulate that with machine learning, not replace it, but as a complementary tool. And we can run our simulations much faster if we use machine learning there. And then in the final step, where we take the data that we've produced through the weather and climate model and process it to either make a new service or post-process it to improve its quality, we apply machine learning there. So, for example, our current weather forecast, we use machine learning to improve our temperature forecast. We know there are deficiencies in some of the physics-based models, so we can use machine learning to improve the quality of, say, our prediction of maximum daily temperature. So it's really all the way through the value chain.
Machine learning capabilities are a main focus for the team at the Met Office, and partnerships are fundamental to their approach. Met Office scientist Dr. Rachel McInnes is co-director of the Joint Centre of Excellence in Environmental Intelligence. Based at Exeter University, they partner with the Met Office and many other research institutions. Here, she describes the importance of such collaborations.
When you're looking at AI and the weather and climate, you really need a diverse range of expertise around the table. Our partnership with Exeter University allows us to bring in expertise from the university side, so some social scientists, some people that are experts in particular types of machine learning, such as large language models, and also the Met Office bringing the weather expertise, the climate expertise, the data scientists.
Rachel then goes on to discuss why a diverse set of people are critical in obtaining results that benefit many, and the importance of reaching out to find the next generation of talent in this field.
So we know that AI amplifies whatever we put in. So any biases that are in the underlying data in AI get amplified and magnified with machine learning and AI. I think it makes it all the more important when we're putting the team together to work on things that we've got a diverse range of voices around the table, that we're hearing from everyone, so that we make sure there aren't accidentally biases in the methods or biases in the data that's going into it. And just generally, diverse teams work better. I think you need the diversity of approaches and the diversity of ideas, and also different lived experiences. And it's the same with climate science. We might have a group of scientists who know about the data, who know about the climate modelling, but really you need to know about the end users, the people who are going to make a decision, the people that are going to be affected by this change. You need their views and their expertise as well.
So, what about the future? Where are we going with machine learning and climate science?
The pace of change with AI and advancement is so fast, it's astonishing, and we're seeing it in every aspect of our lives, really, not just for weather and climate science, of course. If you'd asked me this question a year ago, I would have said, well, I can see this being useful, but I've got some reservations. But now I look at what's happened in the last year, and I'm really convinced that actually we're going to see AI changing our science and changing our capabilities really quite radically over the next 4 or 5 years. So in future, I see us using AI much more routinely in our services. The question will be how we integrate that alongside the physical modelling, and I'm not sure I see how that will work yet, but I only see it's an opportunity. So it's really hard to predict what the future will look like in this space in a couple of years' time, but I do see it being used really in a quite a widespread way.
I think we need to decide where we want to go next, because I think so much of this is possible. It's really limitless in where this could go next. So I think we need to think about these use cases, about how we can help decision makers. We might decide that the most important thing would be to help a region affected by tropical cyclones. We've got a project ongoing at the moment about using machine learning to better model the tracks and the impacts from tropical cyclones, which is yielding positive results so far. So that might be something that we think about, areas that are disproportionately affected by the impacts of climate change, and thinking what AI research can we do to really get the key information into the hands of the people that need to make decisions about infrastructure, about planning.
Now, Spring conditions, albeit a little soggy, are finally starting to assert themselves, and across the UK, parks and gardens are beginning to green up as plant life responds. But climate change is having an effect, particularly when it comes to frost. While frosts can adversely affect tender plants, they're also a vital part of the germination process for many wild species. Hard frosts can also keep harmful pests and diseases in check. And the UK is seeing a general decline in the number of frosts. The most recent decade has, on average, seen the equivalent of 3 weeks fewer ground frosts compared to the period 1961 to 1990. The average date for the first and last frost actually hasn't changed a great deal, and plants lulled into a growth too early in the season may then be at risk if a frost occurs. There is evidence to suggest a warming climate has lengthened the growing season, and with late frosts still occurring, the result is to subject plants to an increased risk of frost damage. Disruptive growth can have a negative impact on wider ecosystems, including reduced carbon uptake and nutrient cycling. The 23rd of March is World Met Day, and to mark the event, the United Nations Development Programme will release a series of videos featuring children from around the world presenting their own future weather forecasts. Set in 2050, the forecasts are based on the latest climate projections and viewed from a child's perspective. Here's Jack with a 2050 forecast for the UK.
I'm Jack with a very special weather report for the year 2050. From down here to up there, everything is crazy. Schools are closed because it's too hot. Wildfires are burning down whole towns, and floods are making everything wet and gross. If we don't listen to scientists, things are going to be even crazier when I grow up. Long heat waves will affect 98% of children in the UK. All this heat could stop us from playing outside for ages. Extreme droughts will wipe out wheat crops, killing the one food my sister eats. Disasters cost taxpayers around the world almost £5 trillion. My parents hate taxes. All of this is caused by a blanket of heat trapping gases in the atmosphere that we should stop releasing more of. But don't worry, there's still a chance of clear skies. Right now, clean energy systems are moving in, creating tons of cool jobs. And solar prices have dropped lower than oil and gas, saving families money that we could spend on other things. A high-pressure system of adults could still move in and protect kids from a flood of really bad stuff. And there's heaps of things you can do today to help stop this. We'll keep you posted as we track whether adults stop wasting time and seriously try to tackle the problem. Because it's not just a weather report to us, it's our future.
Many thanks to future forecaster Jack. If you'd like to do your bit to help protect the climate, head over to weatherkids.org, where you can sign the Climate Pledge and find out more about the work of the United Nations Development Programme. That's it for this edition of Climate Conversations. Do leave your comments and remember to hit the like button. Next month, our theme is oceans and the increasing phenomenon of marine heat waves. How deep does the heat go, and what are the effects on the broader global environment? For now though, from Claire and me, thanks for watching and see you next time.